All right, let's get started. So this is Intro to SQL, SQL Review, somewhere kind of in between. So I want to start by asking you all a question. Let's say we have one of these cool many-to-many apps that we've been working on, where you can store blood oaths, you can add users, you can add songs, you can do whatever it is that we're doing. What happens when you stop running Ruby? What happens to all those things that we added?
Everything you created goes away.
Everything you created goes away. Value of every variable, everything you've set is gone. Now let's say we're an app like MySpace, for example. We don't want, by the way, that's our reference. You guys hear that last night? MySpace lost 12 years worth of music. Like they were doing a server migration and 12 years of data didn't make it along for the ride. Oops. So that's not what we want to happen, right? So how do we do that? We don't want it to like, hey, you didn't kill the Ruby process and lose all our customers' data, right? How do we get around that?
Save it.
Save it? How? Aren't we saving it when we save it in variables?
Save it locally, but again, as soon as we stop running Ruby, it dies.
Yeah. So how do we get around that problem?
Save it not in Ruby.
Save it not in Ruby. Cool. How do we save it not in Ruby?
Teach us.
Anybody have any guesses?
Excel.
Could save it in a spreadsheet?
CSV.
Store it under your bed? Any other guesses?
Somebody push it to an external database.
External database. So we use the word database like it's a big, fancy, scary thing, but it's really just something outside of the program. So that the program is accessing this thing that is secure, lives around, and we can talk to it. We can spin up the app, and that can talk to it. And then another app can spin up, and that can talk to it too. This is the core idea of data management. And what the most common way that we access data is with SQL. Not the only way, but it's the most common. To give you an idea of how long this has been around, anybody watch Star Trek Discovery?
Yes.
So in last week's episode, set 400 years in the future, the Discovery got hit by a SQL injection attack. So apparently, we're planning on this sticking around for a long time. All right, so by the end of this lesson, I'm hoping that every single one of you will be able to do these three things: create tables with SQL, insert, update, and delete data with SQL, and retrieve some simple data with SQL. And depending on how quickly we get through this, I might do a couple other quickies too. Are there any questions before we begin? Going once? Going twice? Sold. So if we look at this first objective, creating tables with SQL. Before we get started with that, we need to create a database with SQL. So SQLite has a really cool utility for, could not be easier for making a database. I'm going to say SQLite 3 and then the name of our database. So if I call this students, name it anything I want, I'm going to name it studentsDB. And that's going to pop me into this interactive SQL terminal. It's kind of like IRB, but it's for SQL. And I can do any kind of SQL statement I want right here in this terminal. And if I get stuck in there, like, get me out of here, I can't control C, I can't do anything. If I type exit, no. If I type quit, no, won't get me out of here. Control D will get us out. Cool thing about that, if we look at our file structure, we have that studentsDB. It's still there. It made a database for us. So the reason that I didn't want to create my database right there in the terminal is I want to be able to make this in a file and then have the database read that in, so that I can use a text editor and not have to like press up arrows and move around the stuff. So we're going to make a file called demo.sql. This could be named anything. We didn't have to use the .db extension. We didn't have to use the .sql extension. But by convention, helps us communicate our intent a little bit. All right, so now I have a students.db and demo.sql. I'm going to open up demo.sql, and I am going to say create table. And I want the name of my table. And then I want to say what things are a part of this table. A really common thing that's going to be in just about all of our tables is an ID, some kind of unique identifier. And the format for this is it goes the name of the column and then the data type of the column. Data type of an ID is an integer. And then this one in particular has a special property to it. Somebody who's done the lab, what's the special property that we add to ID usually?
Prime key.
Prime key or primary key? You say primary key. Let's talk about that for just a second. What is a primary key?
I guess it's like the thing that kind of indexes all the other columns.
Ooh, indexes all the other columns. That's true. How'd you say that as a, so that's how you'd say it as a programmer. How'd you say it as a person? You're explaining this to mom and dad, Johnny or Jane. All right, I'm going to put a minute on the clock. Look it up. What is a primary key? Go. $15 seconds. Okay, so talk amongst your table. See if you guys can come up with a common shared definition of what a primary key is. Go.
It's a value that you use to uniquely identify each row or record in the table. It must contain unique values, it cannot have null values. A table can only have one primary key, which may consist of single or multiple keys.
All right, wrap up your conversations. Can I get a volunteer to tell me what a primary key is?
Sure. It's a unique identifier for each set of data.
Cool. So anybody have anything to add to that? Any other cool things you found?
It's usually a number and often like a sequential.
Often.
There could only be one primary key.
There could only be one. Cool. I think those three things together, that sort of makes up what we need to know about primary keys right now. They're unique. It's usually an incrementing number, and the database handles the incrementing for us. We don't need to handle it ourselves. And there can only be one. If you already have an ID 3, you can't have another ID 3. That's how we uniquely identify a record. And like that makes sense, right? Because if I have students and I start adding other attributes to this, like first name, text, and last name, text, What happens if I don't have that primary key? Exactly. We can have somebody who changes their name. Do all my queries break now? So if I'm accessing them by ID, now I have something that is unique, doesn't change, so on. Cool. So for SQLite, we're really going to be dealing with three different kinds of data. We're going to deal with integers, we're going to deal with text, and if we had like, I don't know, wait, I wouldn't do this to y'all, but you could say real. Any guesses what a real is? Float, decimal, similar kind of idea. But that's how we make a create statement. And if I run this, I can do SQLite 3 demo db, and then that angle bracket, it's called a redirection operator. And then put demo.sql into demo.db. So the way that we'll know that that worked is if I can do SQLite 3 demo db, and I'm back down to this terminal, and if I try to select all from students, I should get nothing back. If I did something that I didn't make, any guesses what I'd get? That's kind of null as what I got before. Some error message. So if I do doesn't exist, table doesn't exist. All right, we successfully created a table. So this was called out to me during the last thing. I heard that some people were exiting out of SQLite 3 and it didn't make the database. Does that describe anybody else?
I think that happened to me on the first one we created.
Curious. All right, let's do one more together, and then we're going to do it on our own. So let's say, give me a thing that we would make a database of. Pets. All right. So what am I going to type in to make my pets database? Somebody else.
SQLite 3
pets.db. All right, cool. Now I want to do this in the text file. I could do it right here. I could just type create table until I make an error, and then I have to kind of press up and fidget around. So how am I going to get out of this? Control D. All right. So oh shoot, it didn't make one for me either. Whoa, weird. All right, we'll figure it out. So it'll probably make it when we throw the query in. So I want to make a pet SQL file. What am I going to put in this? Create table, first part. Cool. Pets. So I'm going to open up some parentheses. And this is the number one reason that you're going to screw up a query. SQL queries always end in semicolons. They're not optional. It will keep expecting more input if you don't put a semicolon in. Helps to put that in as early as possible. Cool, so now we're describing our pets table. Somebody who hasn't spoken yet, what's the first thing that I'm going to put in? Primary key. So what do I type? Ooh, and then something? Or what was that? It's something and then primary key. So what do I put first? ID. Yeah! And then the data type for ID, which is integer. If you work with other database stuff, sometimes it'll be int. No. SQLite 3, it's integer. This is actually one of the things that distinguishes different databases, Postgres, MySQL, Oracle, is what data types they have available and what they call them. For us, integer is what we want to use. Excellent. So what's one other attribute that a pet might have you might want to store? Name? Cool, what's the data type for that? Sweet. So do I need anything else? Cool. So if I do, how do I run this? Cool. What do I type? Yep. And then, maybe remember the redirect operator? Less than. And then, pets.sql. See if it works. All right. How will I know whether or not this worked? I got a pets.db. That's a good sign. How do I find out whether or not my query made the table that I was expecting it to? Cool. How do I do that? Ooh, interesting. I like that. So we're going to do that when we get in. How do I get in? SQLite 3. Pets.db. And then, Sarah, did you have .schema? Yeah. Excellent. Yeah, there's my pets. Rah. So what's .schema do? Shows you the columns. Specifically, it shows you how you made the table, which, good enough, right? Excellent. So let's see if all of us are on the same page. What I want everybody to do is, let me look at let's do person. So I want you to make a person table. Person table should have an ID, they should have a name, and they should have a birth year. So I want everybody to try to make this table in a database. Go. Yes, actually. Capital ZZ. And that saves it in quits. Should you find yourself in that position. Got it? You're on? So. Cool, how'd you know? And then, beautiful.
hit escape. And then hit escape.
All right, another 10 seconds. All right, so give me a thumb scale on this. Did we get it done? Excellent. So I want to chat real quick about Vim, the text editor that I was using. So you guys mostly using Atom? Anybody using VS Code? VS Code people? Any Sublime users? No? All right. So Vim is just another text editor. Does the exact same thing. You can start a file in Atom. You can finish it in Vim. The other way around. Doesn't matter. I'm a Vim diehard. I think I like using Vim more than I like writing software, if that's fair to say. So it's a command line text editor, so there's no other window for it. I would not super recommend that any of you spend any time in the next 15 weeks learning it. I highly recommend that at some point in your career you explore it, because it is fun as hell and it is crazy fast. But the most important question that anybody needs to know about Vim is how to get out. And so should you find yourself with a screen that looks vaguely like this, you can do capital ZZ to get out. And if you find yourself hitting ZZ and it just starts doing that, hit escape. Just hit escape a bunch of times and then do ZZ. And if it goes, hey, no file names, you got stuff in there, then you can do it the long way, which is Q, exclamation point, force quit. Knowing how to quit Vim is a core development skill. Okay, so any challenges? So anybody who didn't quite get this done, anything that was challenging about this in particular? Okay.
I wasn't able to add like the SQL
Mm-hmm.
page I entered, so like when I went to SQLite whatever.db,
Mm-hmm.
it pulled it up like it normally did when I first created the file, and I wasn't able to. I just get that blank line where I was able to. The object.
Possibly an issue with the redirect. So one more time. SQLite 3, name of the program, name of our database, and then less than to redirect, and whatever.SQL to send a SQL file in. Most common thing that gets screwed up, leaving that off. Okay, cool. So that was how we create tables with SQL. Now that we have these tables, let's insert, update, and delete. Let's get some stuff in. Let's mess it around. So for this one, I want to show you guys something that's kind of related to the create tables command. Any guesses what it might be? What's the opposite of that? Delete. Or in database terms, drop. So let's say I go back into that same file, or petsDB or petsql file. So the problem with this is if I run this command more than once, I'm going to get an error. Why am I going to get an error? It's already created. Let's see if SQLite actually barks out the error. SQLite 3 petsDB pets SQL. Table pets already exists. Womp. So this is kind of a problem because if I want to like start with fresh data every time, then I need to like go into the pets database, drop tables, that kind of stuff. So we can make this a little bit more resilient if I drop the table first. So this syntax is super simple. Drop table, pets. Ta-da! And now it's going to get rid of that table and any data that's in it every single time I run this file. We can prove it. If I do that same command I was doing before, petsdb, petsql, I can run it. I can run it. I can run it! So anything else I'm doing in that file, like adding, creating data to it, then that's going to start over fresh every time I run that file. Pretty cool. So if you look in that repo that I sent you, I added a cheat sheet. Oh, this is kind of an interesting side note on that drop table. So take a look at the... Why do I need that?
You can't drop it if there's something to drop.
Right. So the very first time I run that file, it's going to go fail on the first line. Don't have anything to drop. So that if exists will let you run it regardless. Okay, so let's talk about how we add data in. This is the format of an insert statement. I'll also say that like SQL is not that many keywords. It's like 25-ish keywords. And they kind of get used in somewhat cryptic ways. You just memorize them. Or if I'm being honest, look them up every time. I've been writing SQL now for almost 20 years. I have a degree in information systems. I have literally won database design competitions. I usually have to look up the insert syntax almost every time because a lot of this stuff is kind of arbitrary and it changes for every database. So don't feel too bad if you need to regularly look up this information, what I'm getting at. But if we take a look at this, insert into, whatever the table name is, and then what column names you want to include in this insert. This is key because why? Think about that last thing when we were defining the table. What do we not want to insert? The ID. We want to let the database manage the ID. So if we're doing that, we can't just say, hey, insert in the table name, because then we need to declare the ID every time, and that's not what we want to do. So we need to say what column names you want to insert into, and what order we want to insert them in. Because kind of like hashes, there's no like default built-in order for the columns. So we need to say, hey, I want the first name and then the last name. You do the last name and then the first name. Doesn't matter. And then values and what the values for each of those things are going to be. The thing that's easiest to screw up about the insert statement is these GD parentheses, where the commas go, and whether or not you're using single quotes or double quotes and all that sort of stuff. So here's what I want to do. I'm going to go back to that petsdb, or the petsql, and I'm going to add some pets. Except I'm going to do it wrong, and y'all need to tell me what it did wrong. So if I do insert pets values and I do Bixby, I want you to write on your slates what it did wrong. All right, 5 seconds. Hold them up. Excellent. So Shut up! Be quiet! It's like my phone is in the middle of booting up right now, so it's got to finish that whole process. Lo siento. There we go. All right, so I'm missing the into. And what was the other one? The column names. So, like that. All right, let's try another one. Insert into pets name. Oh, actually, a lot of people missed this one. What did I also? Actually, never mind. Onward. What's wrong with this? Write it on your slates. I didn't say hold them up yet. All right, throw them up. Missing the semicolon. Very good. Like I said, y'all will miss this more than anything else in SQL. Or if like you enter something into the SQLite command line and it barfs out, it just keeps going, you're missing a semicolon somewhere. All right, very nice. So let's see. Let's talk about updating. So if I'm updating data, similar kind of thing. This one doesn't have any parentheses in it. We're saying table name, and I want this column to equal this value, and this is important with some constraint on it, or an ID matches, or a name matches, some condition. And the reason this is important is if I just put the semicolon here, leave that off, anybody guess what happens?
It writes the whole column.
For every single record. Yikes. So, let's give this a shot. All right, so if I make this Bixby value, let's see, petsDB, petsql. All right. So I should be able to go into SQLite 3, petsDB, and select all from pets. Cool, I got Bixby in there. Let's say I want to change Bixby's name to Mesa. Pets SQL. What am I going to type in? Update. Pets. Yep. Sure, that works. Could also do it by ID. I kind of like doing it by name though. I think that works. All right, so let's see if that works. Let's run that, and then go into petsDB, select all from pets. Hey, dog's name is Mason now. We updated the data. And let's prove real quick that my horrible fear that I'd change all the values. Let's add another. And I'll call this one Gonzo. And if I take off that where, we should expect everybody's name to be Mesa, right? Let's see if that works. Go into petsDB. Everybody's name is Mesa. Yikes. So, let's take a look at this last one, deleting data. So this one is dirt simple. What does it have in common with the last one?
That's the where.
Has the where. So, exact same problem. If I run this one unconstrained, what am I going to do? Delete the entire table. Ouch. Maybe that's what MySpace did last night. Alright, so I'll set name where name equals Bixby. Alright, now I want to delete Gonzo. What do I type?
Delete from pets.
Cool, so right now I'm wiping out the whole table. How do I...
Where name is equal to Gonzo.
Sure. So what's going to happen when I run this? Hmm?
Yeah, it'll delete those.
Yeah, so it should just have Mesa. Let's see if it works. A victory. Cool. So now your turn. If you look at that file down under Insert, Update, and Delete Data with SQL, there's a MusicDB file. It came down already with your repo. And I want you to insert these 3 records, and then I want you to update Yank Crime to have 11 tracks because they did an extended edition that had the 2-track EP tacked on the end. And then I want you to delete Hot Fuss. So write all the commands to do that. New SQL file, please. And let's go.
Is it case sensitive?
SQL is not case sensitive. You'll notice that me and most folks out there will capitalize the keywords. Makes it easier to see the parts that are your code. I do not believe you need to also make the table for this. How would I know? For the MusicDB? So if I open SQLite 3 MusicDB, I'm in there. How do I know whether or not this already has a table? .schema. Hey, already has a table. Something I'm noticing. What's the name of the database? Cool. What's the name of the table? A database is not a table. A table is a part of a database. Roll safe. What was that? There's just a couple more minutes.
Yeah. So you're in your terminal, it'll be in the database. Didn't like the space.
SQLite 3 using DB, and you're just in that command line.
So I do that after I
Yeah.
ingest it, okay.
Exactly. And like you'll tell because the prompt is different.
How would you say you don't drop with their databases? Like
No, I was misunderstanding the nature of SQLite.
Oh, okay. Yeah. So you just go SQLite tree,
Yeah.
then it does, it's like in memory.
Right. If you haven't added anything.
Yeah.
Is there an easy way to get the code for this?
Get what?
Kind of like just downside to insert this above what I'm doing with it.
Sure. I do not know. You can also like just pull it up in here.
So I'm trying to like enter, and it also have to be in
Nope. So say we put out a moon.
Okay.
And then where's your file? Album SQL? Yes. Alright, if you don't have it, keep working. Elsewise, let's talk about it. What was hard about that? Or like syntaxy tidbits trip you up? Because they're the same ones that are going to trip you up an hour, 3 hours tomorrow. What sorts of things were hanky about the syntax on those 3 commands? So here's the thing I noticed. If I go to like my pet SQL, that insert statement, some things to take note of. Let's say I had some other things like breed. For each one of these, like that, that's a record. That's a record. And so if I have more than one thing on there, then I'd say chow and retriever. And so that's the way we want the flow on that to work. Another thing, it's really easy, or at least I have an easy time, putting too many parentheses on insert statements. So it isn't parentheses around each record and then parentheses around the entire thing. That's not it. Common mistake. There's also no comma after that set of parentheses. There's just little things, and like being able to look at a reference when you do these is helpful in not making those errors. But that's a thing that you're going to be looking for. Another thing that I noticed is, so this is our command line, right? We can do ls, we can do pwd, we can do touch, we can do all the things that we normally do on a command line, right? SQLite 3, that's a different command line. It's got a different set of commands associated, right? So we can do .schema there. We can't do .schema on the normal command line. If we do that, it's going to go, what are you talking about? I don't know that. Another thing, when you do that redirect to run the file, what terminal do we end up in after that? SQL or Bash? Bash. So this is saying, I want you to run this inside of this program. It doesn't put you inside of that program. Cool. What questions do you have about inserting, updating, and deleting data with SQL? Going once. Going twice. Sold. All right, so let's talk about our last objective here. Retrieving simple data with SQL. So if we look at the cheat sheet, oops. This is the format of a select statement in SQL. What do I want to look at? Where am I getting it from? And how is it constrained? In that order. So I think the easiest thing to mix up about this is you can constrain on something that you're not necessarily looking at. So if like it needs to be ID 3, but I don't want to actually look at the ID, all select is what actually outputs from this query. For a simple data set, this is pretty easy. It's just the name of the table. We're also going to talk about how we do this with tables that relate to other tables, that relate to other tables, that relate to other tables. And so that can get fairly complicated. But whatever we're looking at just needs to be somewhere in that collection of data. And then that collection of data is going to start out as every possible record in every table that you're looking at until we start constraining it down. We don't have to. We can look at everything from a table. That's what that select star from table. Show me everything in that table. You can do that with more complicated stuff also. Most of the time, you're looking for something that matches some criteria. Maybe you're looking for a specific record, and that's where these come in. If you have one constraint, it's where. If you have more constraints, each one of them starts with and. You can have one where, you can have a ton of ands. Questions about the format of a select query? All right, let's write one. So let's see. Let's make another database. What's this one about? Food. All right. So this is the let's see. I'll make food SQL. And what's a table in food? That's like a noun that we would want to collect in our food database.
Name.
Name? Oh, like name is like an attribute that something might have, but it also has a weight, and the weight isn't part of the name. So what would we call that collection? What's each individual thing? Sure. So food is our database. So this might have farms, growers, transactions. Each of these could be tables in our food database. What is each individual food thing? What's that called? Dish, maybe. Item. That's probably what I would do. So make like an items table. Create table items, and then what's this ID syntax?
ID, primary, integer, or primary key, integer.
Data type first.
Data first.
Thank you.
Primary key. All right, and then maybe it has a name, and maybe it has a grower.
Calories.
Supplier. Sure, calories. And all right. So I have I have this table. I want to add some stuff into it. Oh, and if I want to run this a few times, what do I do up front? To kind of reset it, drop table It's not going to work the first time though, unless I if exists items. All right, so drop table if exists. I've made the table. Now I want to add some items to it. So what do I type? Insert into items. Then what we do, just name and calories. Or no, let's do name, supply, and calories. I like that. Another thing that's really easy to get mixed up on when you're writing these queries, these are not in quotes. If you do that, it's going to barf at you. When you're typing strings, though, those have to be in quotes. Little stuff like that. I still look it up. All right, so, and then how do I say what I want these records to be? Values. Very nice. And so my first one, how about banana from Kyle Farms, and it's 10 calories. And we'll add a couple more. Let's say Kyle Farms also has tomatoes and potatoes. And let's have Carrie Farms. Carrie, what do you make in your farm?
Strawberries.
Okay. All right, so now I have some data that I can work with, right? Let's try running it. SQLite 3, food, DB. And like, just to be clear, DB is not like a special magic thing. I can call this .database. And run food SQL. Sweet. So now if I go into SQLite 3, food.database, I look at my schema, it's in there. If I look at all of the items, they're all in there. So let's start trying to make some selections. Let's say I just want to get the names of every item that I have. On your slates, write what the query for that would be. I want to get the name of every item. All right, slates up. Good, good. Good. All right, so I saw two answers. I saw select name from items, and that gives us the name of everything. I also saw select star from items. What's different about those?
Star will give you the whole table. It'll give you everything.
Every column. That gives me every column in there. So, cool. What if I want, I want the name and the number of calories. How do I write that query? Slates. All right, states up. Nice, nice, nice. Okay, very nice. So, correct answer. Saw two different answers. You can either say name calories from items. That's going to give us what we're looking for. The other way I saw this was that. So that won't do it, but and is one of our keywords. Anybody remember what and does? What do you use the and keyword for? So what was it? Multiple where statements. Those are all ands. Very nice. All right, so for our simple data, what's where? Or sorry, what's from? What's that always going to be? Whatever table we're looking at. So that one can probably get wilder than any other part of this, frankly. But for right now, all we got to worry about, what table are we looking at? So let's talk about these constraints. Let's say I want to dot clear maybe. Oh. Let's say I want to get everything from Kyle Farms. How do I write the query for that? Go. And Sarah, we're trying to get everything from Kyle Farms.
Can you type in dot schema?
Yeah.
Thank you.
Get every record from Kyle Farms. All right, throw them up. Gotta have the semicolon. Okay, very nice. So I saw two on this one also. Both of them will kind of work, and we'd use them in different places. So what we would do is we could say select all from items where supplier equals Kyle Farms. Cool, so that gives me the three things from Kyle Farms. I also saw this, where supplier like. That worked too. So what's the difference? Any guesses what the difference between where equals and like is?
Like could also include if you had Kyle Farms Inc. and Kyle Farms, but they were separate entities, it would also pull all the entries from Kyle Farms Inc.
I think we're kind of like in the ballpark there. Let's see how true that is. Let's go into this food thing, and let's add Kyle Farms Inc. And Kyle Farms Inc. sells McDoubles. All right, so SQLite 3 food.database, send food.sql to it. All right, and then let's do that like Kyle Farms. Wait a minute, I didn't get McDoubles in there.
Because you use a special that you have to append to the end of those file forms?
Ooh, it's not underscore. Actually, it might be in SQLite. Probably not, though. It's percentage sign. Let's see if this works. So percentage sign is a wildcard. So it needs to contain Kyle Farms, but I could say it needs to have Kyle Farms somewhere in the middle of it. That'll give us my McDouble. I could also say it can have anything you want at the beginning of it as long as it has Kyle Farms at the end. Doesn't match. But I could say it begins. Pretty cool, huh? All right, so let's say, new query. I want to get everything that's over 30 calories. I want to get the name of something that's over 30 calories. Oh, sorry, yes, Jared.
Can you explain then, is one more correct than the other? And if so, why, or in what instance would you use?
Sure. Pause on the assignment for just a sec. Let's talk about that. Where equals versus where like. They don't do the same thing. When would we use one versus another?
Is like case specific? Or not case specific and equals is?
Nope, that's not it.
That's what it said in the bold.
That was in the lab.
Yeah, not in the learn stuff.
It isn't case specific.
It said that like is a case insensitive string comparison, but equals is a case sensitive string.
Sure. So I would think of like as more, I'm not quite sure. It needs to match this, but I don't know that it needs to match it exactly. And so just doing it without any wildcard characters would be a way like, I don't know how this was capitalized or not. It just needs to match this. If you're using a where, you're usually fairly confident about what you're looking for. So you have any uncertainty about how it's capitalized, what it starts with, what it ends with, that's when I would use like. Good question. All right, onward. So the assignment, I want the name of everything over 30 calories. What's the query for that look like? All right, slate's up. Beautiful, 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 beautiful. I can go higher. 30. Ah! Excellent. Everybody got it. So we can write, it doesn't have to be exact matches, it can be comparisons. Greater than, less than, greater than or equal to, any of those things are fair game. So let me see if, let's do one more. All right, I want you guys to do this one. So, this is your final exam on this. I want you to, I don't think I have a movies database. Yeah. All right, let's put it all together. I want you to create a table for this. I want you to insert these records. And let's get that far, and then I got the search that I want you to do. Go for it.
To SQL, this is something else. So get your cursor over it, and press X. Capital ZZ. You used to have that.
All right. Let me get a thumb scale on whether or not you got all those records inserted. All right, I got some people. Somebody who has their thumb up, way up. Would you please post your script in the Slack channel? And then if you didn't get all the way there, go ahead and just run that command. Suppose I could be more specific. Who's on it?
I got it.
All right. All right, so let's take a look at CLARS. All right, so if you didn't have it, just copy this down, put it into a file, run it against your database. Movies DB, could be whatever. Oh, zoinks. Yikes. All right, how do we fix that?
Thank you.
Mm-hmm. Zach, can you edit your?
Yes.
You got more errors too.
Yeah.
Yeah.
Apparently it isn't.
It's working for me.
Oh, it's working
So,
on my
should be-
machine.
Should
I'm
be.
guessing.
Wow, I did that one before.
Did you see that?
Huh?
No, for all.
No, I'm trying to
And like this is maybe one of the most obnoxious things about SQL.
I got syntax errors with his.
Every single database has a
No, no, it's working on my machine.
and in my system,
March
access.
I was using, when I was doing my labs, I was using the codes, apostrophe in there.
Syntax error on line 1 instead of.
Let's try this.
No.
Perfect.
And that would be
Alright,
actual.
so let's see if it's a different.
Okay, so
Drop if exists like this.
There we go. So I had a drop. All right, Zach has an updated body with a primary key on it. All right, so let's look at some stuff. So I'm gonna copy Zach's down also.
Huh? So you drop cable?
So this is movies.
Yes.
All right, so
Yeah.
and we'll say register. All right, and then if I SQLite 3, movies DB, movies SQL, and then SQLite 3, movies DB, and I dot schema. All right, I got it. I'm gonna look at everything in the movies table. Oops. What mistake did I make here? From. All right, I got 4 records in there. So give me a thumb scale. You are up to date. You have records in there. All right, sweet. So, first question. How would I get the name of all of David Wayne's movies? Write it on your computer, not slates. And then eyes on me when you got it, when it works.
What were you looking for again?
I want the name of all of David Wayne's movies.
So, it's so weird. Because I literally just
All right, so correct answer is select. Oh, that's an interesting one. So if I say select name from movies where director equals David Wayne, saw that a couple times. What happened? 99% of SQL issues. But the cool thing is I can just add it and then we're good. Oops.
Maybe it's supposed to be title.
I did the same thing as this thing. The first time.
Good call. Awesome. And then I get back both of David Wayne's movies. So let's say I want everything from this table that was made in the. I like this one. That was made in the 90s. Or no, I take that back. 2000s. I think there's two of them in there. Yeah. I want the movies from the 2000s. So we should get the same results back. Query's going to be really different though. Two different ways you can write this one. Yeah.
Okay. Okay. We do commas after those. Okay. Okay, 2000s. So before 2010 also.
Oh, okay.
Oh. Before 2010.
After 1999, before 2011, 2010.
Now you want to look at it?
Good.
So, yeah, I don't know what you want us to do.
Okay, another 10 seconds.
So you don't want to include.
Beautiful. Womp womp.
Yeah, you gotta do in year. You gotta figure out
Oh, so the issue is that
These are just all one statement because you didn't have that semicolon in there, so you could select twice after the SQL extension. Well, no, so you're in it now. Like all 4 of those lines ran at the same time. Now you can do just that. You might, is it? That's why. So films.sql is your simple file. That's not your database though.
Okay, so I just load it on.
Yeah.
All right, so 2 different ways we could have done this one. First one was select all from, what's it called, movies, where, is it release year or just year? Where year is greater than 1999 and year is less than 2010. That works. What was the other way? 2 of you figured out the slightly more clever way to do it. Between. So we could also say select all from movies where year and then what? Between 2000 and 2009. Same thing. Pretty slick. So you can also, where it can get a little bit crazy also, there's even a thing called subqueries where you can say where the record that I'm looking at is in the result set of this other query. It's an inception of queries. But the format is still the same. We're still just making constraints, trying to whittle down our big list of results. Cool. Questions about retrieving simple data with SQL? Going once, twice. So, our goal was to be able to create tables with SQL, insert, update, and delete data with SQL, and retrieve simple data with SQL. Can you give me a fist to 5, please, where fist is, what are we talking about? And 5 is, I got this, I'm ready to take on the world. What you got? Fist to 5. Outstanding. Very cool. So, time-wise, we are at 11 o'clock. I kind of like to get into joins, but let's flush the brain buffers a little bit. Let's be back here in this room at 11:17. How about? Break. Smoke them if you got them.